So this is the HP that I did an ultrasonic cleanup. So it's been sitting for about half an hour, and then I noticed while it's sitting up there, the USB device keeps going on a loop. So as in, see the sound is gone. That's why it was interesting. When I had the device originally on, I said there is no sound. Sound disappeared, came back. And I thought, oh, maybe it's driver update. It's kind of odd because Windows driver updates works pretty well with audio. So I'm going to plug in a USB, right? I think this guy had some kind of a 5-volt shock somewhere. So that's in. Now let's see what happens here. Okay, that's okay. Sound is now working all of a sudden. It wasn't working just then. Okay, it doesn't have that many partitions. Why does it keep coming up? Let's see what happens. We're just gonna wait. So the USB device is plugged in. It's a very tricky problem. This one has HDMI, so we'll just connect to HDMI. No, we need a display port cable. Or maybe it does it when there's power plugged in. I don't know. Find out. We'll do a dual display. Okay, we've got dual display, alright? So we're waiting for something funny to happen over here. Now I've got to connect it here on the right. When I look at the laptop, I'm going to connect it to the left. Now it sounds it's gone. Oh, here we go. Sorry, because it was going through HDMI. Okay, that's fine. I'll just get the charger while that's still in this mode. Where are you? Are you HP? You are LG, okay. Still nothing. When I have the computer up over there on the bench sitting next to me, all I hear is dun 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 by itself. And I'll show you there a message that was coming up. Yeah, and I won't do it for now, eh? Far out, okay. Yeah. Shit, it's, okay. So, unknown, did it do it? No. Unknown USB descriptor, failed. Unknown USB device descriptor request failed. So that's the message. This generally relates to a hardware fault. But let's see if we can repeat it. And this error was happening without even a USB device plugged in, even though I didn't plug in a USB device. There are still USB devices plugged in, such as the camera, maybe the touch panel. Oh, here we go. There we go. Connect to second screen. And that's me without touching it. Oh shit, wrong camera. Yeah, I'm not touching it. It's doing it by itself. Now it's back. And now it's gone. Okay. I think this is what relates to original problem. Now I'm going to try the USB on this side only, and let's see if we get this problem at all. We're waiting for it to load. USB is still plugged in, yeah? Oh, there we go. So I only got it on the right side plugged in, and we still have the error message. Okay. So what do you think? It's a new Windows 10 install. It is along the USB port, so I've just assembled this unit back. Let's leave this guy out. Let's eliminate this guy. And let's see the reaction. Just to see if we're dealing with a faulty subcomponent. Oh, finally, we can repeat the problem. What's happened there? Did I do something wrong? Charger is plugged in. Yes, we're able to repeat the problem. Wonderful. I'm happy. Give me 1 sec. So, welcome to the problem. Charging light is on. Disconnect that. It won't turn on. So I've disconnected the daughter board only. Let's reconnect the daughter board. Same problem. So that means it's got nothing to do with the daughter board. This board deserves a disassembly. Okay, one more check. He's got nothing to do with it. Alright, we got to go ahead to fix this bent CPU pin, so we have to probably stop this job. Keyboard on the other side. I feel like there's that screw here or something still holding it. We're gonna have to check out like chips like that, which are usually USB controllers. Alright, let me fix that CPU bent issue first and we'll come back. Right, so we're back at this motherboard. Definitely there's a component playing up on this board, so it is currently not in a booting stage. Something's probably maybe shorting something, right? So just have a quick look at resistance mode. You need to make a rule in our diagnostics that multimeter is only for two reasons. It is for diode mode and resistance mode, nothing else. Maybe occasional voltage checking. Okay. Okay. Mega ohms. Okay, 30. These two look like, yeah, these are CPU V-core. You know, our audio chip working and not working, that's the running of the USB. USB port is of 5 volts. I would say it's more of a 5 volt power rail issue than like specific USB controller. Now, let's go to DC mode. Okay, let me see how I'm gonna do this. Power button is on the LCD component. Yeah, okay. Okay, let's bring the power button out to play. You know what, let's just take the LCD out altogether. Okay. Okay, DC jack. Alright, this customer is picking up their PC. I'll be right back. Alright. Currently on. DC mode. That's the guy we're interested in. Sometimes these boards can have two 5 volts. Let me check. Cool. Now will be a good time to... How will I set up my oscilloscope on a camera? I'll just set that up, I'll be back. Alright, so that's the best it's gonna get at the moment. So for now, let's give it a go. So what am I looking at? Mean average 2 volts per division. Oh yes, 1 sec. Alright. Have a peace of mind, okay. So what does the 10 time attenuation? That's going to be 10 times less. It's going to be 1/10 of the attenuation. Here we go, look at that. No power. Good. Okay. Okay. In this mode, where do we have power, where we don't have power? Okay. The BIOS pins, maybe 5 volts, always on. Yeah, so 3.28. It would be nice if it had a better color like that. It would be nice so I can see better. Let me just put something there. Alright, we'll have to do with this. That's the best I can get here at the moment. Okay. The board is currently not turning on. We have we should have that's the 1 volt division. Okay, that's the input of the coil. Now where can I get another ground? You know what to do? A good ground. Let's actually solder a wire. Have a very good wire. Maybe we run from the connection like this. Okay. That's that, and 10 times. Yeah, 1/10. 1x. So we get our 1 volt. Okay, check out the power button area. The power button when I press. Power button pressed. So you can see it going down when I press the power button. Yeah, that is 3 volts. Okay. Yeah, so no problem there. But shouldn't it be 3 volts? But it is 3 volts, isn't it? Yeah. It's 1 volt per division. Why is it 2.4 maximum? Why is it 2.6? Shouldn't it be 3.3? Unplug. Plug it back in. Two 2.6 is fine for it to turn on. Okay, I want to check the 5 volt. Is it always on? Ah. So did you notice we got 5 volts now? Whereas we didn't have 5 volts when it wouldn't want to turn on. See, the board will now turn on, right? Okay, so the board will now turn on because 5 volt always online is present. You see? But the time when it wouldn't turn on, in 5 volt LDO wasn't coming up. It's still, oh, it's still there? Yeah, it's still there. It will still turn on. Okay. Hopefully we can 5 volt always on. If it doesn't come on, then we do know we've got a problem. Board is currently off, so we have 5 volt always on. Well, that's sort of thinking about what to do, whether it's gonna shut off the 5 volt line or not yet. Let's see if there is any schematics for this board. Six 0 5 0 A 2 8 9 2 4 601. Why so long? 6050. Oh, let me try now. 6050A 2892401. Yeah, correct. Yeah, it is correct as I typed. That's the one I've got. Still. I don't think there is a BIOS. I mean, what do you call it? Sorry. The board view or schematics is available. Let's go back to, it's been sitting like this for a little bit. So he's still alive. Yeah, so we'll still, it's a bit dodgy, eh? Okay, so 3 volt. Where's my ground at? Shit. Yeah, 5 volt, still good. It will still turn on. Okay, so we'll still turn on. Yeah, that would be normal. Let's see if we can find out where it's coming from. We'll go in diode mode. No power in the system. APAG 17. APAG 710. It's usually monohelic power systems. So let me just check that again. That was APAG 710. APAG 710. Shit. Nothing's going to come up because AP is the first two letters we need. 1 second. Okay, let's just have a look at this. Okay. Gotcha. NB67 9A. 679. Six, seven, nine. A. I don't have anything. Oh, I do have. No, it's a P channel MOSFET. Okay. Okay. Yeah, monohelic. I was right. The naming convention. Now there may be, there may not be. Synchronous buck converter. Okay, LDO. Yeah. 5-volt LDO. See. Okay. Voltage in. Okay, voltage out. 5 volts. Okay. Enable signal is okay. We're going to enable LDO. Okay. VCC. Ground. Okay. Hmm. So let's check if this board is kind of working or not. Let's make it more advanced. Let's take it up a notch. We'll use the amp meter. I'm very organized now, see? Type-C plugs, and I've labeled every item. It's just a matter of how long this organization will last. It's turning on automatically. 5.2, okay. Let's learn this chip, yeah? Okay. I noticed my phone had some great amazing features I discovered recently. Okay, so what we're gonna do? Take a photo. Samsung Notes, okay. Scan. Cool, okay. So, With the board in this condition being off, so it does turn on. Okay, turned it off. Okay, so just gonna probe this guy a little bit. So BST diode mode. No, we don't want diode mode. So basically I'm gonna update the sheet as I go. BST is, let me check that again, 8.587. Done. And switch, which is going to be the 5.27. Okay, LDO is here. This is LDO 5.27. Voltage out is this guy. Same. So not connect. So that's not connected in this last guy. 1.34 PG. Just check again. 1.34, yep. And then power ground. Oh no. We got this guy here, which is ground, and this guy here, which is 20 volts. Okay. And then we got LP active low 4.88. An enable signal, which is this guy here. No, it's this guy. 2.12. And then ground, so that's going to be ground. This one. Yep. And the last one is here, which is 3.59 VCC. Great. How cool is this? Alright, so we go back here. Cut the power. I mean, iPad you can write as well. I haven't got that feature, pen. So LP we got 4.88. Enable we got 2.12, 3.59 on VCC, 8.58 on BST. Switch voltage out LDO all 5.27. And then 1.34 in the power good. Okay, let's have a look. Supply voltage, these are maximum ratings. Yeah. Okay. Typical. VLP, see, 4.88, 4.85. enable input current, enable, we got 2.12. Okay. VCC regulator 3.59. That's spot on. So I'm just learning the chip here. So supply voltage supplies power for the internal MOSFET and regulator. The NB679A operates from a 5.5 to 24 volt input. So voltage in is 20 volts. Apply at least 2 layers for this input trace. Okay. Power ground. To make the connection, use white PCB traces, enough wires to... Okay. Interesting, I've got 1.34 there. Okay, voltage out. 5. Senses the output voltage of the buck regulator. Okay, connect Vout to the output capacitor of the regulator directly. Vout also acts as the input of the LDO switch over power input. Keep the voltage out sensing trace far away from the switch node. Vout should be avoided on the voltage out sense trace. Okay. Internal LDO output. The driver and control circuits are powered from this voltage. Decoupled with a minimum 4.7 microfarad ceramic capacitor as close to LDO as possible. Once the PG of the power good output. It's not ground. Okay, power good. Okay, power good. Okay, power good out. Okay, sorry. It's power ground. Okay, power good. The output of power good is an open drain signal. It is high if the output voltage is higher or lower than nominal voltage. It is high if the output voltage is higher than 95% or lower than nominal voltage. Okay. So it's staying low, so that's fine, I guess. Okay. Once the power good of the output voltage of the buck regulator is ready, it will switch over the LDO output to reduce power loss. Switch output. Okay. Connect the switch to the inductor or bootstrap capacitor. As switch output is driven up to the VIN voltage by the high side switch during the on time of the PWM QC cycle. Okay. BST. What's BST? Bootstrap. A capacitor connected between switch to form a floating supply across the high side switch driver. Floating. Maybe when it needs more power? I don't know. Internal VCC LDO output. The driver and control circuits are powered from this voltage. Driver and control circuits. Okay. Decoupled with a minimum 1 carrier. Yep. Signal logic ground. Buck enable. Enable is a digital input that turns the buck regulator on and off. When the power supply of the control unit is ready, they drive EN high to turn on the buck. Drive enable high to turn on the buck regulator and drive EN low to turn off the buck regulator. Okay. 2.12 is on. There's a 600 kilo ohms internal pull low resistor. Connect EN for 3.V3 pull up resistor of resistive voltage divider for automatic startup. EN threshold also sets the mode between USM and normal. When EN is in the range of 1.4 to 1.8, it will enter USM. If EN is in the range of 2.6 to 3.6, it's normal mode. Low power mode control logic. It's pulled high internally. That's why we go 4.8. Leave LP open to enter normal mode with a 5.1 voltage out. Drive LP low to enter low power mode with low power then for... Oh, okay. So it's not a low power mode, okay. Now, the board has been in this position. I'll make a note of this for NB 679A HP power in. Okay, let's see the behavior. It's still turning on. Okay, let's have a look at, because he will need MOSFETs to work with, right? Or, yeah. Let's check around there, alright? So, let's bring Mr. Oscilloscope. Let me remove that. Remove, yes. Copy. Paste reference. Okay, there we go. Okay. I'm going to plug in the power and I'm going to check. Let me get the oscilloscope ready. Okay. That's the gate. Let's check there, okay? I'm not sure if that's the 5-volt bit. Just assuming because it's on the other side. That's the gate. The board is currently on. We're on the 2-volt divider. Yeah. So that is definitely the 5-volt. What's the gate? Gate is nothing. Okay. And source. Interesting. Okay. One volt. Let's check here. How come the gate doesn't have any voltage? Hmm? Not gonna touch it. It's still on. Power it off. Oh good, it won't power on. Ah, it powers on, bitch. Let me try again. Okay. How come it's not a 3-volt? It's 2 point something. Let me check the resistance of that MOSFET I've just measured. Cycle any power. Okay. We're gonna do gate to source. And source to drain. And source to gate. All in the high resistance. It's really hard to tell anything. I'm blind as a bat at the moment. A 5 volt descriptor failed message. Well, why don't we just check thermal? Just check what's happening. Just to get an idea. Okay. So now there's no power in the board yet. Okay. Power is plugged in. Board is turning on. I'm gonna tell it to turn off. Okay, the board is currently off. Okay. So it's pulling 0.028, which is nothing. Okay, let's go and have a look at the 5 volt buck converter. Okay, here we go. CSSD. Really? That SSD gets that hot? These are all going to be hot, so it's all normal. Really? 60 degrees. Very normal behaviors. Okay, so let's plug in a USB. Is that a normal working temp for an SSD? It's quite mental, that one. The board is going to sleep. Power button. Alright, great, it won't turn on. Thank you, don't turn on. Okay, the board is not gonna turn on. Quick, let's investigate, quick. The board will not turn on. Something is amiss. Okay, careful. Okay, DSO. Okay, yep, 1 volt per division. Ground is good. Oh, we still have 5 volts. Okay, power button. No reaction. .36. That is not my power button. 3.2, nope. 2.16, that's my power button. Okay. So my initial jump at this is incorrect. That's fine. Isn't there supposed to be like a 1 volt, 1.2 volt, another voltage line to be on? Okay, that's what I mean. That's also on, yeah. Something is telling the board not to turn on. Okay. Let's just remove this SSD while the board has power. It turned on without the SSD. This is what was powering the SSD, I believe. Well, it was getting as hot as the SSD. I'm just measuring randomly. Okay. 256 Toshiba. Let's see if the same reaction happens with another SSD. I'm gonna put it in while the power is in, but turned off. So it's normal for it to get hot. So what we'll do is check the thermal camera again. Okay, we don't need to worry about DSO. Wow, this guy's even crazier. Is the board still on? Yeah. Wow. Okay. Now, it would be nice to repeat the problem with a different SSD. Power off. Power on. So it registers the power button press even though it's 2.6 volts. Okay. Let's plug in a... These guys all have Windows 10. We'll connect a HD display port. Okay, we'll lose the connection. Get a keyboard and mouse. Okay, we only got 2 ports. We need more ports, okay. So now it's booting. Let's see. Now this guy doesn't have Wi-Fi. Wi-Fi, USB, where are they? I think I've got one somewhere. Can I connect a network cable? It will be difficult. Let me see. Quickly search our online database. SB2C7. 2467. Gotcha. Okay. Okay, I'm not sure if the USB hub can carry the USB Wi-Fi as well as the keyboard and the mouse. Oh, it can, great. Oh, this is the inbuilt Wi-Fi, okay. That's fine, we haven't got the antenna wire, so we'll just disconnect the dongle I plugged in, okay. Okay, so here we'll go online and do its device updates. Here. That's the touch screen. But mainly we're interested here if any of the devices like the extensible USB controller, etc. is gonna give us that error message as before. Yeah, descriptor. I2C device. That's interesting. I2C bus. I've seen similar issue with firmware. It's usually. Interesting. Alright, I'm gonna have to, I guess, let this update run if it finds anything, etc. And I'll see if the freezing issue happens or not. Not freezing, shutting down issue. And for now, I'll leave it at that. Oh, here we go. Look at that audio. It disappeared again. See that? So damn interesting, isn't it? Audio chip comes and goes. I mean, I don't mind replacing the audio chip if that's what the cause or issue is. Now I'm curious, right? Let's shut this computer down. Where are you? Okay, it's shutting down. Let's wait for it to gracefully shut down. Okay, finally, okay. Turns on, okay. So, after this, right, which will be tomorrow, I'll have a look at the audio chip, which could be a false alert. But let's see if that I2C error will disappear after removing the BIOS chip, audio chip. The SSD gets really hot. Crazy hot. See the audio chip? It says can't find it now. Because rarely does Windows have issues with audio chip in terms of drivers. You only need to install the drivers to get maybe additional features or maybe channels or inputs, etc. I don't know. Somehow this version of software is shit, as you can see. We'll let Windows do the rest. And we'll have a look at the audio chip later. So I'll stop the video for now. See you later tomorrow.
Thanks for watching. Please subscribe to support this channel.